Welcome all. Today we will see about the nomenclature. It means that the system of naming the organic compounds. So in this, proper name is given to the particular organic compound on the basis of certain standard rules so that study of these compounds may become systematic. In these two systems of nomenclature, we can see one is the trivial or common system of nomenclature, another is IUPAC system of nomenclature. So, IUPAC means International Union of Pure and Applied Chemistry. So, in trivial name, in this organic compounds are named on the basis of their source of origin. For example, citric acid got its name from citrus fruits. Formic acid got its name as it was obtained from red ant. Urea. Urea got its name as it is obtained from urine of mammals. Methyl alcohol is obtained from destructive distillation of wood, and acetic acid is obtained from vinegar. Let's see some more examples for trivial or common system. CH4. This is methane. Next is butane. CH3, CH2, CH2, and CH3. Next is isobutane. Then next, neopentane, formaldehyde, CH3C double bond OCH3 acetone, CHCl3 is chloroform, CHI3 iodoform, CH3COOH acetic acid, C6H6 benzene, C6H5OH, that is phenol. Now IPAC system of nomenclature. So in this we have the basic rules. In IPAC system, the naming of organic compound consists of three parts. That is word root or root word, both are same, then suffix, then prefix. Word root. Word root indicates the number of carbon atom present in the chain. That is, it indicates the carbon length, CC length. If only one carbon is there, then we can say the word root is myth. Then again carbon has 4 valency. If we have 2 carbon atom, then the word root is eth. All 4 valencies we have to show that. Then if the carbon has 3 carbon atom, the length of the carbon chain is 3, then it is prop. If the length of the carbon chain is 4, then it is but. If the length of the carbon chain is 5, then it is known as pent. Then if it is carbon chain length is 6, then it is hex. Then if it is 7, it is sept. Then if it is 8, then it is oct. Then if it is 9, it is non. Then if it is 10, it is dec. So word root indicates the parent chain in the hydrocarbon. Next is the suffix. So there are two types of suffix. One is the primary suffix and another one is the secondary suffix. So in primary suffix indicates the nature of the linkage in the hydrocarbon, whether it is saturated or unsaturated. So saturated means which have CC single bond, and unsaturated means in which we have CC double bond or CC triple bond. For example, alkane. So this is hydrogen, 2 carbon is there and 6 hydrogen is there, and CC is a single bond. So this is alkane. So word root is eth. So the name is ethane. If there is CC double bond, then we can say that is alkene. So carbon has 4 valency. Here one hydrogen, hydrogen, 1, 2, 3, 4, 1, 2, 3, 4. So this is C2H4. So primary suffix is "ene" and the word root is "eth." So the name of this is ethene. If we have CC triple bond, primary suffix will be "ine." So C triple bond C H H. So word root to carbon eth. The name is ethine. Then if we have two C double bond C, then we have to use the prefixes di. If there is 3 C double bond C, then we have to use the prefix triene. Let's see one example. 1, 2, here we'll put 2, double bond, 3, 4, 5, 6. So all 4 valencies of carbon, 1, 2, 3, 4, hydrogen, 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 1, 2, 3, 1 hydrogen here, 1, 2, 3, 4, 1, 2, 3, again 4, 1, 2, 3, 4, 1, 2, 3, 4. So let's name the compound 1 carbon, 2, 3, 4, 5 and 6. So here the name is 6 means the word root is hex. Hex, and the double bond is in the second carbon and in the fourth. We have to take the lowest number. It should not be right double bond is in third and the fifth. So double bond is in the second position and fourth carbon. So hex hyphen 2 comma 4 hyphen di in. Like this we have to name the organic compound. Then if we want to name the, or if they have 2C triple bond C, then the prefix will be diene. For example, here C triple bond C, one hydrogen here and no other hydrogen because all the 4 valencies are satisfied here. Then C, one hydrogen, single bond C, triple bond C, then one hydrogen, one hydrogen, one hydrogen. Let's count 1, 2, 3, 4, 5 and 6. So the name will be, here again the triple bond is in the first carbon and in the fourth carbon. So the name of this will be hex hyphen 1 comma 4 hyphen diene. This is how we have to name this compound by using the prefixes. For the, if there are 2 CC triple bond, then the prefix we have to use is 1, 4 diene. And before that, and if there are, we have 3 CC double bond, we have to use di, like this. So this is the about the primary suffix for the alkanes, alkenes, alkynes and alkadiene, alkatriene and alkadiene. Now is secondary suffix. So secondary suffix will indicate the functional group in the organic compound. So organic compound alcohols, the functional group is OH and secondary suffix is ol. So what are the functional groups? So functional groups will determine the chemical properties of the organic compounds. So you can say that the carbon atoms, it may be defined as the atoms or group of atoms which makes carbon compounds or organic compounds reactive and determines its chemical properties. So the organic compounds which have same functional group will show same properties, and the organic compounds which have dissimilar functional group will show dissimilar properties. For example, all alcohols show same properties, all aldehydes show same properties, but alcohols and aldehyde properties will be different. The next is aldehyde. Functional group is CHO. Secondary suffix is al. Then ketone, C double bond O. Secondary suffix is on. Carboxylic acid, COOH is the functional group. Secondary suffix is oic acid. Esters, C double bond OOR. And the secondary suffix is O8. Acid chlorides, COCl. Secondary suffix is oil chloride. Acetamides, functional group is CONH twice. Secondary suffix is amide. Nitriles, C triple bond N. Secondary suffix is nitrile. And amines, NH2. And secondary suffix is amine. Now we will see the IUPAC name of the functional groups for haloalkanes. In IUPAC system, haloalkanes are named after the parent alkane by using prefix to show the presence of the halo group. Halo group means halogen group. Halogen group means fluorine, chlorine, bromine, iodine. These all are the halogen groups. So let's see one example. C H H C H Cl H. So here we can say since we have two carbon, so we can say that the word root is it, and the side chain, that is the chlorine, is present here. So chlorine. Chlorine will be, we can say it's a functional group. So the IUPAC name for this compound is chloroethane. Next example. So this it can be written, this one it can be written as C2H5Cl. Next CH3Cl. We can take this also. So if you're naming 1, 2, 3, so here chlorine is in the second carbon and the longest chain is the 3. So it will be propane. So we can say the name is the chloro will be act as a side chain. So 2 chloropropane. The IUPAC name is because to indicate the position of the chlorine in this compound. So 2 chloropropane. Next, let's see another functional group, that is alcohols. So again, alcohols in this, the functional group is OH. So alkane minus E plus ol, we get alkanose. So for example, we'll take one example, CH3OH, or you can also write it as CH3OH. So since it has only one carbon, so we can say that it is meth. Plus again we have all single bonds are there. So N, and the functional group is ol. So the IUPAC name of this is, see, one important thing you have to remember is whenever the suffix, that is the functional group. Whenever the secondary suffix, that is the functional group, starts with any vowel. So any vowel means A, E, I, O, U. Then the N. Then the in the N E is dropped out. And then we have to write the name as methanol, Methanol. This is the name of the this compound methanol, not this one Methanol. This is not. So whenever the secondary suffix starts with any vowel, then in the alkane the E is dropped out, and then we have to write the name of that compound. Let's see another example for this. C H. Always try to write the structural formula so that you will not make any mistakes. H and H. This can also be written as C2H5OH, or you can also write it as CH3CH2OH. Since two carbon carbon chain is there, so the word root will be eth. CC single bond, so it is N, plus secondary suffix is here OH, secondary suffix is ol. So the IUPAC name of this compound will be ethanol, ETHANOL. So NOL. So here again we can see the secondary suffix starts with vowel. So hence E is dropped out. So this is the name of the compound is the ethanol. Next. Next is the another compound is functional group is aldehydes. So aldehyde the functional group is C double bond O H. So again how we will name it as alkane minus E plus al, that is alkanes. Let's see one example for this. C H H H C double bond O H. So this is the functional group. Functional group is also known as secondary suffix. Since only two carbon is there, so we can write it. The name is ethanol. The name of this compound is ETHA, ethane. So same thing you can ethanol. Same thing eth plus n plus al. So again it starts with the vowel al. So again e is dropped out from the n. Next example we can see 1, 2, 3 double bond O H. This is the aldehyde. Then satisfy all the carbon with all the four valencies. So the name aldehydes, this is a functional group. It should get the least number. So first carbon, second carbon, and third carbon. So how you will name that? Again, prop propanol, the compound. The name ending should be al only. Prop, you can write prop in al. So again, this is dropped out. The name will be propanol. This is how we have to name this compound. Next is ketones. The functional group for ketone is C double bond O. This is the functional group of the ketone. Again, alkane minus E plus one is equal to alkanone. Example CH3COCH3, or you can also write it as C. Write the full structural formula: CH3, C double bond O, CH3. So we have 1, 2, 3 continuous carbon chain. So the word root will be prop, and the functional group is on, ketone. So the name of the compound is propanone. Let's see another example. CH3, CO, CH2, CH2, CH3. Or you write the full structural formula: CH3, C double bond O, CH, CH2, and CH3. Here the continuous carbon is 5 carbon length: 1, 2, 3, 4, 5. So the word root will be pent, and the functional group is ketone. So secondary suffix will be on. So always remember that the functional group should get the least number. If we are counting from the left side, the functional group is getting the second number. If we are counting from the right side, so it will be 1, 2, 3, 4, and 5. So here, if we are counting from the right side, it is getting the 4. So the functional group should always get the least number. So this is the correct name. We have to count from 1, 2. This one is the functional group is in the second position. So the name of the compound is PENTA. See again, pentane to on. So same thing, we have followed the same rule, that if we will break this, it will be pent plus an plus on. Since secondary suffix starts with the vowel, that is O, so the in the n e is dropped out. So we will write as PENTAN, pentane. 2 means ketone group is present in the second position, and on is a functional group. So this is the IUPAC name of the compound. Next is the carboxylic acid. It's an another functional group. C double bond O, O, H. This is the functional group. So we will name it as alkane minus E plus oic acid is equal to alkanoic acid. For example, let's see the example. HCOOH, or you can also write as H C double bond O, O, and H. So one carbon is there. So the word root will be meth. So methanoic acid, and the functional group is OIC, C double bond O, OH. The name of this compound is methanoic acid. Let's see another example. CH3, COOH, or you just write the full structure: CH3, C double bond O, OH. So we have two continuous carbon. So the word root will be eth, and the functional group will be oic acid. So the IUPAC name of this compound is ethanoic acid. Let's see another example for this compound. CH3, CH2, COOH. Or you can write CH3, all the four valencies of the carbon you can show it, H2, C, 1, 2, 3, 4, O, and then H. So again the functional group should get least number 1, 2, 3. So the word root will be prop. So the IUPAC name of this compound is propanoic acid. So these are the functional groups how you have to name through these rules. Next is alkene group. So alkene groups are represented by general formula Cn H2n, where n is the number of carbon atoms. And these alkenes means they have C double bond C. So these are known as unsaturated hydrocarbons. So alkenes we can say one example. Just write down the structural formula CH3 C H double bond C H H. See the four valencies of carbon 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So in this two carbon we have only, in this we have two hydrogen, in this we have one hydrogen. If suppose if you have to fit this one in this formula also, you will get C, where n is the number of carbon atoms 1, 2, 3. So C3 H 2 into 3, that is C3H6. So once can count 1, 2, 3 C, one hydrogen, second hydrogen, third, fourth, fifth, sixth. So C3H6 is the hydrogen. Uh, C3 and H6 is the hydrogen, 6 hydrogen. Here we have two double bonds are there between the carbon 1 and the 2. That is why the name ending will be "ene." So the IUPAC name of this compound is propene. Since double bond is present in one carbon, so you can write propene or one propene or just propene also. It is correct. Next, alkyne groups. Alkyne groups, the general formula is CnH2n minus 2, where n is the number of carbon atoms. In this, they contain C triple bond C. And these are also unsaturated hydrocarbons, means which contains double bond or triple bond are called unsaturated hydrocarbons. Let's see one example. C, C, C. You'll keep three triple bonds, one hydrogen, 1, 2, 3, 4. So no hydrogen in this carbon. One hydrogen, hydrogen, hydrogen. So the formula, if you will put in the formula, then C3H2 into 3 minus 2. That is C3, 2, 3 just 6, 6 minus 2, 4. Then is C3H4. Now you count 1, 2, 3, 3C, 1, 2, 3, 4. 4 hydrogen. So the word root 3 carbon means the word root is prop. And the what is the suffix here? Ine. So the name will be propine. Propine 1 or 1 propine. Both are okay. Next is the prefixes. So prefixes, it indicates about the substituent or the side chain. For example, alkyl group. Alkyl means alkane minus hydrogen, that is alkyl. For example, CH4, this is methane. minus hydrogen, we will get CH3. This is methyl. So this will act as a substituent or side chain in the organic compound if methyl is present. Another example we will see C2H6, that is ethane, minus hydrogen, we will get C2H5. So this is ethyl. Next, functional groups which are not regarded as the primary functional groups. So so they will act as a secondary functional group. So when an organic compound which contains two or more than two functional groups, then one of the functional group act as a principal functional group and other will act as a secondary functional group, or it may act as a substituent, or it may act as a side chain, or it is indicated by the prefix. So we have to see the preferences. If two or more functional group is present in organic compound, then we have to see the preferences. So in preferences, first preference will be given to the carboxylic acid group, that is COOH. This is the first preference. Then it is more than the sulfonic acid, that is SO3H. Then next preference is the acid anhydride, C double bond O, O, C double bond O. This is the next preference is esters, C O O R. The next preference is acid halides, C double bond O, Cl. This is the functional group. Then next preference is given to amide, C double bond O, NH twice. The next preference is given to nitrile, C triple bond N. The next preference is given to the aldehydes, that is H, C double bond O. Then next preference is given to ketone, C double bond O. The next preference is given to alcohols, that is OH. Then next is amines, NH twice. And next is ethers. So this is a functional group we have to remember while naming the organic compound which contains two or more functional groups. And all the remaining groups such as halo groups fluoro, chloro, bromo, iodo, nitroso, nitro, alkoxy, these all are treated as a substituent or the side chain or secondary functional group or prefix. So nitroso, NO, OH, hydroxy, OR, alkoxy, OCH3, methoxy, CN, cyano, CHO, formyl, SO3H, sulfo, then fluoro, chloro, bromo, iodo, nitro, amino, NH2, and N double bond N, that is diazo. Let's see one example which contains two functional groups. So we will write with the structural formula CH, H, C, H, Cl, C, H, H, C, H, H, O, H. So here we have the two functional group. One is the alcohol and other is the chlorine. So according to the preference, we have seen here that preference is alcohol will get more preference than the halogen. So that is why it will get the main functional group. This will act as a main functional group. and this will act as a side chain, or you can say as a substituent, or it is also known as secondary functional group, or you can also say it as a prefix. Now let's see the IUPAC name of this compound. So IUPAC name of this compound is, so the we have 4 carbon, 1, 2, 3, 4. So 4 carbon means the word root will be, 4 means the word root will be but. Then all are having CC single bond. All are having CC single bond. That is why primary suffix will be ane. Primary suffix is equal to ane. And chlorine act as a substituent. So the prefix will be chloro. Chloro will be the prefix. So we can name this IUPAC compound as, the functional group should get the least number. So we will count from the this carbon 1, 2, 3, 4. Since chlorine is present in the third position, we have to indicate that. So first the name will be, it will be like this, chloro, then but plus ane plus ol. Again, if we see the functional group, it is starting with ol. Here the secondary suffix that is the main functional group is ol. So secondary suffix of main functional group starts with vowel O. So the E of the N will be dropped out. So the name of the compound will be chlorobutanol. Since chlorine is present in the third position, so the final IUPAC name of this compound is 3 hyphen chlorobutane hyphen 1 hyphen all, because alcohol is present in the first carbon. So this is the IUPAC name of this compound. So 3-chloro, 3-chloro-butane 1 ol. So this is how we have to see if more than two functional groups are there, then according to the preference you have to name the compound. Then complete IUPAC name of organic compound is represented as prefix, then word root, then primary suffix, then the secondary suffix. Let's see example for this. CH3, CH3, CH, Cl, CH2, OH. You can write like this also, or better you write full structural formula so that you will not make any mistake. CH3, CH, Cl, CH2, OH. So we can see now you write. So what is the word root? Word root is 1, 2, 3 carbon. So 3 carbon means word root is prop. Prefix secondary, because here alcohol and chlorine is present, alcohol will get the first preference and chlorine will get second preference. So the prefix will be here, prefix will be chloro, then primary suffix. So primary suffix all are having CC single bond. So the primary suffix will be ane. Primary suffix is equal to ane. And we have the secondary suffix. Secondary suffix indicates the functional group. So secondary suffix is ol is equal to ol. Now according to this First we have to write prefix, word root, primary suffix and the secondary suffix. Now you count carbon 1, 2 and 3. Chlorine is present in the second carbon. So for the prefix chlorine, before the chloro we have to name the position. We have to tell the position. So the answer will be, it will be, so you can also write that chloro. Then what is that? Chloro. Then we have prop plus an plus ol. Again secondary suffix starts with vowel, so e is dropped from the n. So the final name of this compound is 2 hyphen chloro, because in second position chlorine is present. So 2 chloro propane hyphen 1 hyphen ol. You can write like this, or you can simply write 2 chloro propanol. It means that if you write like this also, it is understood that the alcohol is present in the first carbon only. So this is the complete IUPAC name of the compound according to the rule. Okay, first it should be prefix, then word root, then primary suffix and secondary suffix. So this is the prefix, this is the word root, this is the primary suffix and this is the secondary suffix. So prefix will indicate the substituent, word root will indicate the carbon length, and primary suffix indicates the carbon-carbon linkage, whether it is alkane, alkene or alkyne, and secondary suffix indicate the functional group. Let's see some more examples. We'll write CH3, CH, NH2, CH2, C, CH, OH, CH3. So it's better you open the structure and write, so it will be easy for you to name the organic compound. So first CH3, the same compound I am writing, I am just opening the structure. CH, then NH2, then C, H, H, C, H, OH, then C, H3, this. So in this, the main secondary suffix, that is the main functional group, is the alcohol will get the first preference and amine will act as a substituent. So this is the main. Here in this compound we have two functional group, but according to the preference alcohol will have more preference than that of the amine group. So alcohol will act as a main functional group. So accordingly the rule is that we have to write the prefix. We have to write prefix, then word root, then primary suffix, then secondary suffix. So prefix is the amino group, plus word root is the pent. Since all are carbon-carbon single bond, so primary suffix will be ane and secondary suffix, the main functional group, will be ol. Again, the main functional group starts with the vowel a, e, I, o, u starts with vowel, so the e of the n will be dropped out while naming the compound. Since amine, next is amine group is present in the fourth carbon. So count the number 1, 2, 3, 4 and 5. So 4 hyphen amino pentane hyphen 2 hyphen ol. Why we are putting 2? Because the alcohol group, the OH group, is present in the second carbon atom. So we have to mention the position of the alcohol. So we have to mention the position of the main functional group, and we have to also mention the position of the substituents. So the final IUPAC name of this compound is 4-amino pentane to ol. So you have to write like this: 4 hyphen amino pentane hyphen 2 hyphen ol. So this is how you have to name the organic compounds by using all the important factors, like you have to see the word root, you have to see the primary suffix, you have to see the secondary suffix and the prefix. So let's have a quick recap. Word root will indicate the carbon carbon length or the main parent chain. Primary suffix, it will indicate the carbon carbon linkage, whether it is CC single bond is there, or CC double bond is there, or CC triple bond. Means it indicates whether the compound is saturated or unsaturated. Saturated means alkanes and unsaturated means alkene or alkyne. Then secondary suffix. Secondary suffix will indicate the main functional group in the organic compound. Then we have to see the prefix. Prefix will indicate the substituent or the side chain or the secondary functional group. So by using all this, we have to name the organic compound. Thank you very much.